concavity of a graph is going to deal with the second derivative. So we're looking at f double prime of x. And when f double prime of x is equal to 0, we're going to have what's called a point of inflection or an inflection point. And what an inflection point is going to mean is it's a switch from either concave up to concave down, or a switch from concave down to concave up. Okay, so a graph is concave up when it's opening up. So this particular graph is concave up for this whole section until about right here. At that point, the graph is going to become concave down until it switches concavity about right here. And then it's concave up again, opening up till about right here, and then it switches back to concave down. Okay, so what this means, when the graph is concave down, that means that the second derivative is negative. So f double prime is less than 0. And then when the graph is concave up, the second derivative is positive. And then these switches in concavity are inflection points, which I'm going to abbreviate as IP. So here is an inflection point where f double prime is equal to 0. Here's an inflection point where f double prime equal to 0, and then here is another one. Okay, and we see that at those inflection points, the graph is either switching from concave up to concave down, or from concave down to concave up. Okay, so now let's talk about what this means, especially in terms of the first derivative. And remember, first derivative, we can think of that as the slope of the tangent line at a point. So I'm going to write, we're just going to kind of guess at some first derivatives or slopes of certain points of this graph, and I'm going to use m. So f prime, m for slope. We're going to see what that might be at these points. So let's say right here, we're going to say that the slope there, well, it's negative and it's pretty steep. So maybe the slope there is -4. And here it's still negative, but maybe -2. Here at the local minimum, the slope is 0. And then after the minimum, the slope is positive. So maybe here the slope is 2. It's getting a little steeper, so the slope is 3. And what we see here is that for this little section where the graph is concave up, the slope of the graph starts off negative, and then it's increasing to a smaller negative number, then it's increasing to 0, increasing from 0 to 2, and then from 2 to 3. So when the graph is concave up, the first derivative, or we can think of that as the slope, is increasing. Let's look at this other section of the graph to look at a concave down section and think about the same thing. So right here at this point, the slope is maybe 3, and then because it's positive, it's a positive slope. Here the slope is still positive, but perhaps a little bit less steep. So we're going to say the slope there is 1. At the local max here, the slope is 0. And then here the slope is negative. Let's say it's -1. And then here the slope is still negative, but it's steeper, maybe -3. So if we look at what's happening to those numbers, we're starting off with large positive numbers, like 3, and then decreasing to 1, decreasing to 0, decreasing to -1, decreasing to -3. So for this whole section, f prime, or m, is decreasing. So we can make a connection here that when the graph is concave up, that means that the first derivative is increasing. So whenever the second derivative is positive, that means the first derivative is increasing, or the slope is increasing. And whenever the first derivative is decreasing, that means our graph is concave down, which means that our second derivative is negative. So whenever our second derivative is negative, we're going to see that the first derivative, or the slope, decreases for that interval. So this is just an introduction to concavity. We're now going to look at the second derivative tests and tests for concavity.